When working with functions, we can take different functions and put them together in pieces with different domains, and it's called a piecewise function. So our objective here is that I can graph piecewise functions. What I want you to do is notice here that we're given in this function 3 different rows, and on each row there's a rule defined and a domain. So what you have to do is treat this as looking at this rule following this domain, this rule follows this domain, and this rule follows this domain. And we're going to graph them on the same graph. So if this first rule, if I'm going to do this one in green here, it's going to be for all the values less than 0. And then when I do the next one, which I'll do the negative 2x plus 1, do that one in red, that comes from 0 all the way to 3. And then once I hit 3, the next function takes over, and I go from x is greater than or equal to 3 and on. From there on out, that's going to be my blue function, or 5x minus 17. So let's do these each, so treat them individually. Do each as a separate problem, but just stop the graph where the domain ends. So this first one, x cubed plus 1, if I put in negative 2, negative 1, I'm going to put in 0. Even though it doesn't include 0, I'm going to see where that graph would take me, and I'll put an open dot on it because it's less than. So negative 2n cubed is negative 8, plus 1 is negative 7. Negative 1 cubed is negative 1, plus 1 gives me a 0. And then 0n cubed plus 1 would give me a 1. So let's plot those points. Negative 2 comma negative 7 is down here. Negative 1 comma 0 is here. And then 0, 1, I'm going to put an open dot on it, so it curves like this and stops there, but there's an open dot on that spot because it doesn't include the 0. Okay, now let's do the next one. Let's do negative 2x plus 1. That's a linear equation. So what we'll do is we'll start with, we're going to start with 0, and we're going to go all the way to 3, though I won't include 3, so I'll do 1 and 2 in between. Putting in 0, I get negative 2 times 0 plus 1 is 1. We put in 1, we get negative 1. We put in 2, negative 4 plus 1 gives me negative 3. And then put in 3, you get negative 6 plus 1, which is a negative 5. So we plot those points and we get 0, 1. Now that is an included point because of that. So when I go to this open dot, because 0, 1 is included, I'm going to fill in that dot. So actually the closed dot from the previous one gets filled in because these two meet. Then I do 1, negative 1 right here. I do 2, negative 3 right there. And then I do 3, negative 5 right there. So this is a straight line that goes down like that. And it's an open dot at the end at 3 because it does not include that point. So now let's try the last one. We're going to start at 3 here for this last one. So we'll put in 3 for x. I'll just put in 4. It's a linear equation, so if I get 2 points, I can plot the graph. So if I put in 3 here, I get 15 minus 17 is negative 2. Put in 4, I get 20 minus 17 is, I get 20 minus 17 is equal to 3. And so now I plot those points. I get 3 comma negative 2, which will be right here. Now notice this is a different point than that one, so it doesn't fill it in like the other one did. So this stays open, but this one's closed because of the or equal to. And then I plot 4 comma 3. And then I've got my line, which keeps going off to this end. Okay, and I'm just going to complete this one here because this doesn't stop at negative 2. The domain keeps going, so I'm going to have the graph keep going from there. So that this domain is less than 0. This one's between 0 and 3, that part of the graph. And this part is from 3 on, what the graph looks like. So piecewise functions, you treat them as separate problems, focus on doing the graph, but only with the x values outlined here, and then stop it where the domain stops, and then pick up and do the next rule where those x values are for a chart for us. Complete that graph and then do the last one, and you have your piecewise function.